Why is space dark? But there is light on the Earth. People often look up and ask, why is space dark? The person who asked this question, and it's often explained in many different ways. Among them, mixed with complex concepts such as relativity and cosmology, and simple concepts like refraction of light. Of course, these explanations, often wrong. When we say wrong, because the person asking the question almost always cuts two. However, different phenomena are confused, although they all involve space and darkness. One problem is that, why is the sky seen from space? It's always completely dark, even in the presence of the sun. Here's another problem. If there are indeed billions of stars in the universe, enough to cover the entire celestial sphere, why can't their light be like the sun? Illuminate our night like that during the day. Friends, if you would like to come with me, because this topic is really complicated. April 12, 1961 at 9:07 a.m. Moscow time. Rocket engine ignition lifts off, sending humans for the first time into space. This astronaut is known to be Yuri Gagarin. His first words after entering orbit were, "The sky is black, completely black, and at the edge of the Earth, near the horizon, there is a beautiful blue rime. I can also see the stars from here." At that time, this is already known theoretically in the scientific community, but Gagarin's personal experience to help explain this counterintuitive phenomenon into the public field of view. It certainly is. The original question seemed at first glance very simple. If you ask a primary school student, the most predictable answer you might get is, no sun at night. The light of the stars is too weak, can't light up the night. That's not a bad answer, but at least it's incomplete and simplistic. People tend to think that we can't see stars during the day. It's the sunlight. Far from it. The real reason why we can't see stars during the day, because of the Earth's atmosphere. The gases that make up the Earth's atmosphere, able to scatter light from the sun evenly, make it look like it's coming from anywhere. And not just the sun. It's a bit like when you're at night, encounter the headlights of another car while driving. If the night is dry and clear, the headlights only illuminate the respective sections. But if the night is foggy, you'll see a white wall. Stop you from seeing the way. The edge is on the moon without an atmosphere. Even if the sun is high on the horizon, the sky is also black. In any other rock without an atmosphere, on the stone planet, the same thing will happen. So, in a nutshell, space looks black because he is empty. The reason why he is black, it's not because he's dark. It's because there's no matter there. There's nothing there to illuminate. Light travels in a straight line, won't touch any. Something that can scatter it in all directions. Even on Earth, if we go in a hot air balloon, rising to approximately 32 kilometers, 20 miles up, we will see the color of the sky gradually change. Dark blue. Then it turns purple. And finally, the absolute black of interstellar space. We can even see the stars. Think about it at that height. We still can't say we're in space. There is no exact starting point in space, because the atmosphere is gradually thinning. However, there is a so-called Kármán line, located at an altitude of 100 kilometers and 62 miles. According to international treaties, this is usually where space begins. At an altitude of 32 kilometers, we're still completely in our atmosphere. You might be surprised to learn that, from a technical standpoint, even the International Space Station, moving at an altitude of 400 kilometers and 250 miles, is still thought to be within this gas layer. This gas layer may have been extended. It extends 2,000 kilometers, 1,250 miles. Great to have this. We arrive at the other side of the original problem, although similar in darkness and space. But what he has discussed with us so far, very different. That if the universe is so vast, there are countless stars, why is the night sky dark? Shouldn't all the stars in the universe be? Is it evenly lit? After all, there are stars and galaxies in the sky. Suppose the universe is infinite. They will be so many, so that they will be like the sun in white. Light up the night sky like the sky. The answer to this question, unlike the answer we just discussed. In fact, the evolutionary history of our universe, closely related to fundamental cosmological questions. This is discussed now with a 19th century German astronomer, Olber's name. Connect together. He also discovered asteroids, Pallas and Vesta, and some comets. The idea of the universe at that time is based on the so-called perfect cosmology principle. He pointed out that the universe is infinite, no privileged location or direction. And over time, under these assumptions, for the sake of simplicity, suppose all stars are the same brightness. Radiant energy reaching the Earth, just a single circle of light, degree multiplied by the number of circles. Since the volume is infinite, the number of circles in the total radiant energy must be infinite. It's British Thomas Digges broke the stars. Ptolemaic dogma fixed on a crystal ball. 1576. He revisited the concept of infinite space. This was Democritus's idea 2,000 years ago. He strongly supports countless stars, a vision of an infinite universe spread evenly. Which brings us to the problem we're dealing with. If the universe were infinite, then the number of stars that fill it is infinite. Why is the night not as bright as the day? His answer was, the farthest star is too faint. Their light cannot reach us. But as we shall see, he was wrong. This argument was also settled by Kepler in the 17th century. Later, Halley and the Swiss astronomer Jean Philipp Sassel revisits. Sassel did not offer a better solution. We will see the light absorption problem. But he succeeded in refuting Digges' answer. Prove that every star even. The furthest one should be right. Reaching the total brightness of our night sky contributes. Once Digges is caught, prove wrong. The issues remain unresolved. Go on, haunted the best minds of the day. And there are plenty of caveats. One of the first ones considered was by Sassel himself. Suppose there is a large amount of interstellar dust. Can prevent observers from seeing the farthest stars. Indeed well known. Observations at low latitudes, near the plane of our galaxy. There are regions represented by the so-called Milky Way, due to the presence of dust. It's very problematic, for example. The distribution of research and foreign aid. These areas are deliberately excluded to avoid systemic effects in data analytics. However, from the perspective of Olbo-Speth's theory, this defense is wrong. Any absorber, for a long enough time, will reach thermodynamic equilibrium with the light hitting him and start sending out as much energy as it receives. Reinvent the original problem. Another possible explanation is that although our universe is infinite, but only a limited number of stars. However, observations of the amount of luminescent matter estimated so big, so much so that they did not solve the theory. Even though the number of stars is limited, the night sky will still be bright. In the 19th century, Herschel was the first to propose the so-called layer, people with sub-solutions. It was later adopted by many other astronomers. Until the beginning of this century, the model is based on Kant's idea of hierarchy, proposed a series of increasingly large galaxy clusters, like a giant Matryoshka doll. Can prove. If larger clusters of galaxies are smaller, low enough density, this can solve the problem. A more modern version of this model, circle-based typing distribution, when viewed at different scales, they look the same. For example, stars could indeed be infinite, but their arrangement makes them seem dense. The trunks of the forest are hidden behind each other. By this means, only a limited area of the sky will be bright. The argument will be resolved. This solution may seem artificial and snack, but it is correct in theory. For example, if the stars are distributed in a fractal fashion, there may be a large area of sky with no light source at all. The sky will look completely dark, except for small areas. It is worth noting that, about the size of galaxies and galaxy clusters, recent observations of the spatial distribution of scales data, it seems that, at least on a limited scale, sub-model agreement. However, scale up this model to a much larger scale, and the cosmic microwave background observations of radiation contradict. This is currently considered to be the universe. Uniformity on a large scale, type and all the same, the most convincing evidence of sex. Cosmology solves the back theory, the modern view of the universe. The law is very different from the last century. On one hand, the general theory of relativity developed by Einstein. Space and time are connected. Because the speed of light is finite, due to the impossibility of exceeding go at this speed, communication always has a limited time to connect to two different regions in the universe. On the other hand, in 1929, Hubble observed a galaxy in the spectrum. The red meter of some lines discovered the expansion of the universe. This is predicted by general relativity, so the perfect cosmology principle fails. The universe is not an unchanging universe at all. There is an evolutionary process. Its properties therefore change over time. The development of the theory led to the Big Bang. The model also predicts an initial time, about 13.7 billion years ago, the expansion of the universe. Since then, this model predicts the so-called cosmic world. It surrounds observers who can look towards the Earth, the area where the optical signal is transmitted. The solution to the fundamental equation of this model, a Russian mathematician, Friedman's name, indicates that the area is limited, rather than infinite. Based on these new explanations, it's rather complex, so I can't explain it clearly for me, or worse, if my explanation is boring, I apologize. There are two possible explanations for Olbers' theory. The first possible explanation is that the universe is expanding. Therefore, the light emitted by distant celestial bodies will be reddish. This is due to the so-called Doppler effect. The whistle of the approaching train sounded sharper, and away from the train whistle, it sounds lower. It has the same effect. For the most distant objects, this red instrument will be so big that would prevent their observation. The second is due to expansion. Distant stars and galaxies, the energy emitted will spread through a larger volume. it appears weaker to observers on Earth. The conclusion of these two factors together means the received total brightness is not infinite. They're finite. From this perspective, the darkness of the night sky, it's actually evidence of the expansion of the universe. In the Big Bang model, another possible explanation for Olbers-Betz theory, from the age of the universe, due to his relatively young age, and not forever. Galaxies can only emit radiation for a limited amount of time, apparently less than the age of the universe, because they need some time to form. Therefore, not enough time to reach will make the night sky like a constant, a thermodynamic equilibrium as bright as the surface of a star. The two solutions are different, but it can be seen through the current cosmology. The Big Bang model is connected. As we can see, he predicted the finite age of the universe and his swelling. So understand these two effects. Which one of them explains the theory? More important becomes important. Recently, it has been possible to solve this problem quantitatively. Shows that both effects are important, but to varying degrees. The finite age of galaxies explains intergalactic radiation, also known as the extranuclear light background, the reason why the strength is reduced by a factor of 10, and the effects of the expansion of the universe can only be explained 3 times lower. So, although some professional cosmology books claim that Olbo, the solution to Speyr's theory, is not pure essential relativity, what is really decisive about the effect is, in the history of the universe, there was a time. There was no galaxy like the one we know today. Therefore, it is impossible to fill the universe with visible radiation. And in the end, we were left with tremendous satisfaction. When we gaze out the window at night, sky time, we are actually conducting a simple, but very important cosmological experiment. What do you think of this civilian team? Welcome to leave a message to discuss.